Okay. So this is the first question. We are given some matrices A, B, and C, and we have to determine these two matrices. Okay, so for the first one, 1.1.1, we want AC transpose. Now what you need to remember is this is equal to C transpose multiplied by A transpose. So if the questions say to you, work out AC transpose without first multiplying A and C, then this is what you need to do. You find the transpose of C, the transpose of A, and then you multiply them. But because this question just says to determine their products transpose, you don't need to use this formula, even though if you did, you would get exactly the same answer. Okay, so we can start by multiplying AC. So we put the two matrices together. We have 2, -1, 3, -2. And then here we have C, which is -3, -1, 1, -4, 2, and -3. Okay, so we know how to multiply matrices. It's a row with a column. So we will have 2 times -3, which is -6. And then you add 3 times -1, which is -3. So that was the first row with the first column. So the sum goes in the first row, first column. So first row, second column is over here. So we have 2 times 1, which is 2, plus 3 times -4. This is -12. And then 2 times 2, that's 4. 3 times -3, that's -9. And then -1 times -3, that's +3. -2 and -1, that is +2. Then -1 and 1, it's -1. -2 and -4, that is +8. -1 -2, then -2 -2, that is 6. So our matrix A6, this is -9. Here we have -10. And then over here we have -5. I hope this will fit. Okay, and then we have 5. We have 7. And we have, okay, so that is AC. And now to work out AC transpose, the rows become columns and so on. Okay, so what you will get is this matrix over here. We have -9, we have 5, we have -10, we have 7, we have -5, we have 4. Okay, so this is the matrix AC transpose. So as an exercise, you could try working this out. First find C transpose and then A transpose and then multiply them. You should still get this one. So the next question was to find A transpose. So we have our matrix A over here. This is 2, 3, -1, -2, and we have to work out its inverse. So to work out the inverse of A, we first need to work out the determinant of A. Make sure it is not 0, because a matrix whose inverse is, whose determinant is 0 is singular. That means it does not have an inverse. So the determinant, we say the product on the major diagonal, so 2 times -2 minus the product on the minor diagonal, so 3 times -1. So this is -4 plus 3. this is minus 1. So minus 1 is definitely not equal to 0. So we can say that the inverse exists. Okay, so now because the inverse exists, we can work it out. And with a 2 by 2 matrix, finding the inverse is very easy. So we have 1 over the determinant of A, and then here we multiply by the adjoint of A. So we take the matrix A, the elements on the major diagonal, we swap them. So minus 2 comes here, and then 2 goes there. And then these 2 on the minor diagonal, we multiply them by minus 1. So 3, we multiply by minus 1, and then minus 1 times minus 1 is positive 1. So this is 1 over negative 1 times minus 2 minus 3, 1, 2. And this gives us 2, 3, minus 1, minus 2. So this is the inverse of A. And how do you test whether this is in fact the inverse of A? What you do is you can multiply A, this matrix A, with A inverse, and you should get the identity matrix. Okay, question 1.2, we are given points on a rhombus. So with these shapes, nobody is going to define them for you. So we expect you to know what makes a shape a rhombus. So this point P is minus 1, minus 2, 1. And then we have 2, 2. We have 5, 6. Okay, and we are told that these diagonals meet at a point M over here. All right. Now, one thing, or what we should know about a rhombus is that a rhombus is a parallelogram. It's a special type of parallelogram. And the thing is, all sides are equal. Okay, so that is what makes a quadrilateral rhombus. Okay, now 1.2.1, we have to determine the equation of the line QS. So because this is a parallelogram, a rhombus is a parallelogram, then it means this point here, M, where the diagonals meet, is the midpoint of PR as well as the midpoint of QS. That is one of the properties of a parallelogram. So to find M, we just work out the midpoint of PR. So we say minus 2 plus 5, we divide this by 2, and then 1 plus 6, and then we divide this by 2. So this gives us 3 over 2 and 7 over 2. Okay, so now when we look at this line QS, we have 2 points that lie on the line QS. To find the equation is very simple. We use y minus y1. This is equal to y2 minus y1 over x2 minus x1 multiplied by x minus x1. So this is the formula we use when we are given 2 points on a line. So my Q will be x1, y1, and my M, the coordinates, will be my x2, y2, and then I'm just going to substitute. So y minus y1, I have y. This is equal to y2. This is 7 over 2 minus y1, which is 2 over x2, 2 minus 2 multiplied by x minus 2. So from here we have y minus 2. Here 7 over 2, that's 3.5 minus 2, that's half. And then in the denominator, we have 1.5 minus 2, that's minus a half. And then x minus 2. So this is negative 1. So we have y minus 2 is equal to minus x plus 2. So our equation of QS, so QS has the equation y is equal to minus x plus 4. Okay, so that is the equation of the line QS. Then the second question, say 1.2.2 says find the coordinates of the vertex x. S, sorry, not x. Okay, so we know the midpoint of QS. We have the point Q, so we just use the midpoint formula. Okay, 1.2.2, we want the coordinates of S. So this point here we can call X comma Y, and by the midpoint formula, we know that X plus 2 over 2 and y plus 2 over 2, this should give us the coordinates of m. Okay, and the coordinates of m, we'll work them out over here. This is 3 over 2, 7 over 2. So that means we have x plus 2 over 2 is equal to 3 over 2, and y plus 2 over 2 is equal to 7 over 2. So from the first equation, we have x plus 2 is equal to 3. This means that x is equal to 1. And here, y plus 2 is equal to 7, which means that y is equal to 5. So S has the coordinates 1, 5. Question 2.1, we have to prove this identity. So when you're proving identities, remember that you need to work on one side only, until what you have is the same as the other side. So usually you want to pick the side that looks more complicated. So here the left-hand side looks more complicated. Once you've picked a side, you need to write it down. So this is 1 over tan A plus cos of 90 minus A over cos A plus 1. Okay, then we have an identity for the difference of angles. So we have 1 over tan A plus the identity is cos of 90 times cos of A plus sine of 90 times sine of A, and this is all over cos of A plus 1. Okay, so this leaves us with tan of A. Now cos of 90 is 0. Okay, so I have 0 here, and sine of 90 is 1. So I have 0 plus 1 times sine A, so that is sine A over cos A plus 1. Now 1 over tan A, that is cos of A over sine A, because it's the reciprocal of tan. Tan is sine over cos, and 1 over tan is the reciprocal. So the reciprocal is cos of A over sine of A. So we have plus sine A over cos A plus 1. Then if we're to add these two fractions together, cross multiply, this times cos A plus 1 plus sine A times sine A over sine A times cos A plus 1. Okay, so this gives us cos squared A plus cos A plus sine squared A all over sine A times cos A plus 1. Now, our famous Pythagorean identity, cos squared A plus sine squared A, that is equal to 1. So I have cos A plus 1 over sine A times cos A plus 1. So these two will cancel. So I have 1 over sine A, and 1 over sine A is, in fact, cosec of A, which is our right-hand side. We have to solve for theta in this equation. So when you're given these questions, always remember the steps. Step number 1 is you need to make sine, cos, or tan the subject. So here I have 1 minus 3 cot theta is equal to 4.5. Okay, so I can rewrite this as 3 cot theta is equal to negative 2.5, negative 3.5. Okay, so this is negative 3.5. So cot theta, this is negative 3.5 divided by 3. That is 7 over 6. So cot theta is equal to negative 7 over 6. And we know cot is the reciprocal of tan. So this means that tan theta is equal to negative 6 over 7. This is step 1. So step 1, you want to make sine, cos, or tan the subject. We have done that. Step number 2 is your reference angle. So we have alpha. This is equal to tan inverse. I have a negative here. I am going to ignore it. I'm going to take tan inverse of 6 over 7. Okay, this is 40.6 degrees. Now, the third step is your quadrants. Now, because this is negative, you ask yourself, in which quadrants is tan negative? And the answer is the second and the fourth quadrant. So in the second quadrant, theta is 180 minus alpha. So this is 180 minus 40.6. And this is 139.4. Okay, and then in the fourth quadrant, theta is 360 minus alpha. So this is 360 minus 40.6 degrees. This is 319.4 degrees. Okay, so the next step is usually where we would add 360 and see if the angle we get is still in the range. But you can see that if you were to add 360 there, it would not be in the range. So we would stop there. So with trigonometric equations, remember the steps. Step number 1, what you need to do is make sine, cos, or tan the subject. Step number 2, find the reference angle. Step number 3, decide on which quadrants your answer is going to come from. Step number 4 is find the answer or your angle in a quadrant. Step number 5, which has a star on it because sometimes it's not necessary, is you add or subtract 360. Question 2.3, without the use of a calculator, determine the exact values. So when you're asked to solve something like this without the use of a calculator, it means you need to draw the special triangle. So there's only two of them, so you should know them. The first one is the one with 45 degrees. So here you have 1, 1, and the square root of 2. And then with the other one, I have 30, I have 60, and this is 1, 2, and square root of 3. Okay, so I have sine squared of pi over 5 plus cos squared pi over 5 plus tan of pi over 4 plus cos of 60 times sine of pi over 2 minus pi over 3. This is all over 2 cosec of 90 times sine of 45. Okay, now pi over 5 is definitely not a special angle, so there is no triangle that we can draw to work out what sine of pi over 5 is. But what we notice here is we have our identity, sine squared plus cos squared. It doesn't matter what angle you have there, as long as the two angles are the same, this is always equal to 1. And then tan pi over 4, that's tan of 45, which is 1. Cos of 60 is half. And this one, sine pi over 2 minus pi over 3, we can work it out using our identity. This is sine pi over 2, which is 90, times cos pi over 3 minus sine of pi over 3 times cos of pi over 2. And then in the denominator, we have 2 cosec of 90, that is 1 over sine of 90, and sine of 45 from our triangle is 1 over the square root of 2. So this then gives us 1 plus plus 1 plus a half. Sine of pi over 2 is 1. Cos of pi over 3, this is a half, minus sine of pi over 3, this is the square root of 3 over 2, and cos of pi over 2, this is 0. And this is all over 2 times sine of 90 is 1, then multiplied by 1 over the square root of 2. So when you're asked to do it without a calculator, show as many steps as possible. I want to be convinced that you did not use a calculator. So this is 1 plus a half. Here we have a half. 2 times 1 over square root of 2 is square root of 2. This is 1 plus a quarter with the square root of 2. And this is 1 plus 1 1/4. This is 5 over 4 over the square root of 2. And this is 1 plus 5 over 4 square root of 2. Now it did say in the question to leave as a single fraction, so you'll have 4 square root of 2 plus 5 over 4 square root of 2. Okay. Question 3. Given f of x is equal to e to the power of x plus 1, x is greater than or equal to 0, and g of x is 4 minus x, and x is a real number, find f inverse of x. So what you do is you first say, this is for you first let y is equal to e to the power of x plus 1. And then where you have x, you replace the x with y. And where you have y, replace the y with x. And then you make y the subject of the formula. So you take ln of x on both sides. So we have ln of x, this is y plus 1. So y is equal to ln of x minus 1. Okay. This is our f inverse of x, and we write f inverse of x. This is equal to ln of x minus 1. And here x must be greater than 0, otherwise this is not defined. Then 3.1.2 says find f of g of x. So f of g of x. So into the function f, we are going to, instead of putting x, we're going to put g of x. So we're going to put 4 minus x. So that means in the function of f, where we have x, we replace the x with 4 minus x. So this is e to the power of, not x, but 4 minus x plus 1. This is e to the power of 5 minus x. And then it says, hence evaluate f of g of 5. So that means in this function here where you have x, you're now going to replace the x with 5. This is e to the power of 5 minus 5, which is e to the power of 0, which is equal to 1. Determine the following indefinite integral. So we have the integral of e to the power of 60 plus, this one here, we can simplify it. So it's 6t cubed over t cubed minus 7 times t to the power of minus 3 dt. Okay, so I have integral of e to the power of 6t plus 6 minus 7 t to the power of minus 3 dt. So we know how to integrate this. First, it remains the same. Then you divide by the derivative of 6t, which is 6. The integral of 6 is 6t to the power of 1 divided by 1. So don't need to write that one. And then we have minus 7 t to the power. At the top we add 1, so we get minus 2, and then we divide minus 2. Then don't forget to add the constant of integration. So this is 1 over 6 e to the power of 6t plus 6t. Then negative and negative will give us positive 7 over 2 t squared plus c. 3.3, determine the derivative of this. So before I differentiate, I want to rewrite it. So I'm looking for d du of this. You can write as u to the power of minus a half minus k u e to the power of minus 1, and then plus 3 over 4 ln of u. Okay, so now differentiating, we have here the exponent will come down. So we have minus a half u to the power, at the top we subtract 1. And then here minus k. So k is a constant because the variable of interest is u. So this will come down. So e minus 1. At the top, you subtract 1. You have e minus 1 minus 1 is e minus 2. And then we have here the 3 over 4 must remain there. Then ln of u, the derivative is 4 and not u. Then we have 1 over u. Okay, then simplify it. This is 1 over 2 u to the power of 3 over 2. And then here we will have, I can write this as k minus e, u e to the power of minus 2 plus 3 over 4 u. Question 3.4, we are given the function y is equal to 12 over x minus 2 and show that the equation of the tangent to the curve at the point A is given by this. So whenever you're asked equation of the tangent, you need to know, okay, I need to differentiate, and that gives me the gradient of the tangent. If I have the gradient of the tangent, I have the point of tangency. I need to come up with the equation of the line and then show that it's equal to this. So differentiate, we say dy x. This, we have to differentiate this. Now our y, we have y is equal to 12 over x minus 2. This we can write it as 12 x minus 2 to the power of minus 1. So when we differentiate using the chain rule, the minus 1 must come down. So we have minus 12 x minus 2 to the power of minus 2, and then multiply by the derivative of the inside, which is 1. So I don't even need to write it because the derivative is 1. So I have minus 12 over x minus 2 squared. Okay, now I work out the specific gradient when x is equal to 6. So the gradient when x is equal to 6, we have minus 12 over 6 minus 2 squared. This is minus 12 over 4 squared. This is minus 12 over 16, which is minus 3 over 4. Okay, so now I have the gradient. The formula we know is y minus y1 is equal to mx minus x1. So this is my x1, y1. I just substitute and show that I can write it in this form. So we have y minus y1, y minus 3 is equal to minus 3 over 4 x minus 6. So y minus 3, this is minus 3 over 4x, and then negative and negative will give us up to 18 over 4. Multiplying everything by 4, from here we have 4y minus 12. This is minus 3x plus 18. Okay, then bring everything on one side. We have 4y plus 3x, and then we have minus 12 minus 18. This is minus 30 is equal to 0. And that is exactly what we have there. Okay, so we have shown it. Okay, a structure moving in a straight line is used at a construction site. Its velocity in meters per second at time t is given by this formula. Determine when the body comes to rest. So again, these keywords that we need to know, that at rest means that the velocity is 0. Okay, so if the velocity is 0, we have 2t, 8 minus a half t is equal to 0. So this means that 2t is 0, or 8 minus a half t is 0. So here t is 0, and then here we have 8 is equal to a half t. So this means that t is equal to 16 seconds. So the first time it comes to rest that means it starts from rest because time is 0, and it comes to rest when t is 16 seconds. So after it's 16 seconds. 3.5.2, we have to determine the distance the object moved during the first 3 seconds. Okay, so we're looking for the displacement. We know that S is equal to the integral of the velocity with respect to time. Now, the first 3 seconds, that is from 0 to 3. And we're going to integrate. So integrate from 0 to 3. And here, we're going to multiply out. So I have 16t minus t squared. T. Okay, so this is the integral of 16t, that is 16t squared over 2 minus t to the power of 3 over 3 from 0 to 3. This is the integral of 8t squared minus t cubed over 3 from 0 to 3. And this is 8 times 3 squared minus 3 cubed over 3, and then minus 0. So when I substitute t0 here, I'm just going to get 0. So 8 times 9 minus 9. This is 27 divided by 29. So this is 63. Okay, then determine the time at which its acceleration is 11. So 3.5.3. We have the acceleration. This is the derivative of the velocity with respect to time. So we take our formula for the velocity, it's here, and then we differentiate it. The derivative of this, so our velocity, I'm just going to rewrite it here. This is 2t, 8 minus a half t. So I'm going to use the product rule to differentiate it just for practice, because we always need to know all the techniques that we're given. So the product rule says we must differentiate 2t, which gives us 2, and then the bracket must stay the way that it is. Then you add the first one the way that it is, and then the derivative of the bracket, which is minus a half. Okay, we multiply out the brackets. This is 16 minus t minus t. Okay, and this gives us 16 minus 2t. And if you differentiated this, you get 16 minus 2t. So either way is fine. Okay, so we want the time when the acceleration is 11. So acceleration is 11. This means that 16 minus 2t is equal to 11, which means that 2t is equal to 16 minus 11. So 2t is equal to 5. This means that t is equal to 5 over 2 seconds. Question 4.1, we are told that two circles with radius 8 centimeters and 5 centimeters are placed on a flat ground, partially overlapping. So you have one circle like this, and you have another one like that. These are partially overlapping. Something like that. They intersect at this point A and B, and we're told the radius. So the radius of this big circle here is 8, and the radius of this small circle here is 5 centimeters. Okay, and they intersect at these points. The distance between their centers is 10. So the distance from there to there, this is 10 centimeters. Calculate the common area. So this area here is what we are trying to work out. Okay, so you can see what we have is we have sectors like this. So these of this area there. And then we have the other one. Like that over there. So when we put these two together, this shaded area and this, it gives us the area that the two circles have in common. So what we need to do is work out the shaded area on this side here. Let's see if I can use a different color. So we have the red side here. So that's this one here. And then we have the black one over there. So when we add the red and the black together, it gives us the total area that we're looking for. So here we are given, this is 8, this is 8, and this is 5, this is 5, and then the distance between these two is 10. Okay, so we also have this shape here. It looks like this. Okay, it's not that good. Okay. So we have this distance there is 10, and okay, so from there to there, that is 10 centimeters. This is 8, this is 8, and that all together is 10. So this is obviously 90 degrees. This is 5, and this is 5. Okay, then this one here, we can break it up and look at it like this. So this is something like that. So you have 8, 5, and over here we have 10. So these two angles there, we can work them out, and then that will help us to work out the segment areas. Okay, so we have all the sides. We need the cosine rule in order to work out these angles. So we know the cosine rule. We call this a C, even though I think here the centers are OQ. This the letters in the question. Okay, so we have QO, and we call this P. Okay, then this is side small q, side small p, and this is side small o. So if you remember from the cosine rule, we have that o squared, this is equal to p squared plus q squared minus 2pq cos of angle O. So if I want to then make O the subject of the formula, we have cos of O. This is equal to p squared plus q squared minus O squared divided by 2pq. And then I find O by taking cos inverse. So O is equal to cos inverse of p squared. So this is 10 squared plus q squared plus 8 squared divided by 2 times 10 times 5. So this you do on your calculator, but we're not really interested in angle O. We're interested in this angle here, which is a double of O. So 2 times angle O inverse right, this should be minus. This is minus, not plus. Okay, so that gives us 52.4, and double of O is 104.8. Okay, this is in degrees. Now, for the formulas that we're going to use, our angle will have to be in radians, so you need to keep that in mind. So the same thing if we want to work out angle Q. So this is cos of Q. This is equal to P squared plus O squared minus Q squared over 2P times O. Okay, and then Q, this is cos inverse, and now we substitute P squared is 5 squared plus 10 squared minus 8 squared. Sorry, that's not right. So P squared is P squared is 10 squared. O squared is 8 squared. Q squared is 5 squared. Okay, so this we have 10 squared plus 8 squared minus 5 squared over 2 times 8. This gives us 29.7. And then 2Q, the angle that we're looking for, this is 59.4. Okay, so we have worked out these two angles here. So the first one, this is 104.8 degrees, and this one is 59.4 degrees. All right, now to find the shaded area, okay, so now to find the shaded area, we need these two angles to be in radians. So 101.8 degrees. To convert it to radians, we multiply by pi over 180, and this will give us this gives us 509 over 900. Okay, and then 59.4 also multiplied by pi over 180. This gives us 33 over 100 pi. Okay, so now we want to work out the segment areas, the black one and the red one, and then add them together. Okay, so we know that the area of the segment is the area of the sector minus the area of the triangle. So we start with the black area, writing black there, and then I will just add. So it's the area of the sector. So this is a half. Our angle theta, half theta times the radius squared. And then we subtract the area of the triangle, which is a half r squared, the radius squared, times sine of 101.8 degrees. So my calculator is in degree mode, and because I'm using sine and this angle here is in degrees, I can leave it like that. I can also write sine of 509 over 900 pi, but when I type it in on my calculator, I need to make sure my calculator is in radian mode. And then for the red one, do something similar. So for the red one, so this area here, we are going to add it to the area of the sector. So it's half the radius, or half theta first, 33 over 100 pi times the radius squared minus a half the area of the triangle, half times the radius squared times sine 59.4. So if you write sine of 59.4, make sure your calculator is in degrees. If you write sine of 33 over 100 pi, make sure your calculator is in radian mode. Okay, so these angles here are dependent on whether the angle your calculator is in degree or radian mode. But these ones over here, they must always be in radian. It doesn't matter, or it doesn't affect your answer whether your calculator is in degree or radian mode. Okay, so all this we do on our calculator. Okay, so you should then get 27.732. So just go over my calculations and make sure that the calculations are correct. So the method is fine. You must just follow the method. So just check that the actual number values are correct. Okay, so for the last question, we're given these 3 points, and we are told that QPR is 90 degrees. Find the value of M. So we have 3 points. We have point P here, we have Q somewhere there, and then we have R somewhere there. So this angle here is 90 degrees. So it means that these vectors here, they are perpendicular. And we know that perpendicular vectors have a dot product of 0. Okay, so what we need to show is that PQ dot QR is equal to 0. What we need to use is this fact. So we need to find PQ. So PQ, this is minus OP plus OQ. Okay, so minus OP, since this is the point, the position vector is just the coordinate. So we have 1, minus 2, 4. And then OQ, this is 2, 0, minus 1. So this is 3. Sorry, not 3. We have minus 1 plus 2, that's 1. This is 2 plus 0, and then minus 4 minus 1, which is minus 5. And then we have QR. This is minus OQ plus OR. Don't forget the arrows. So this is minus OQ. This is 2, 0, minus 1. Plus OR, we have 0, M1. Okay, so this gives us minus 2 plus 0, minus 0 plus M, then 1 plus 1 is 2. Okay, so we have our two vectors PQ and QR. Now, because they are at 90 degrees, it means they're perpendicular, so we find PQ dot QR. So this is 1, 2, minus 5, dot. So it's very important that you put a dot here and not a multiplication sign, because with vectors, the dot and the times sign, they mean different things. So this is 1 times minus 2 plus 2 times m plus minus 5 times 2, which is 0. So we have minus 2 plus 2m minus 10 is 0. So 2m minus 12 is 0. So 2m is equal to 12. So m is equal to 6. Okay, and that is how you answer the questions.